Simon McAuliffe. I'm a Chief Scientific Advisor at the Essex Council, and also at the same time a professor at University of Essex. So let me introduce Spiros Mafrakis. I'm butchering this.
That's perfect. That's absolutely perfect.
Who is Assistant Director in Institute for Analytics and Data Science at Lions at the University of Essex, and also a lecturer in artificial intelligence at the University of Essex. So he will describe how we get rid of humans and letting the machines take over today.
Well, perfect. So, thanks everyone. Thanks for inviting me. This is a short presentation about, generally speaking, a bit of the history of artificial intelligence and data science, and how people in the past have made use of data science and artificial intelligence to drive forward certain projects in the public and private sector, and how we are using it here in Essex as a university. So, I'll start with a very brief introduction on data science, then I will proceed talking a bit about artificial intelligence and how it evolved through mostly the Cold War. Some examples of where we stand with all this. I mean, things that are happening around the world. This is a very exciting time for artificial intelligence as a field. Then I'm going to talk a bit about the impact of AI on society, or what people think is the impact of AI in society. No one is really sure what's going to happen. And then I'm going to describe a certain mindset that will possibly get you into that idea of innovating and discuss a bit more about this. Right? So, better science to data. Right. So, there's something called the Turing Award, which is effectively the Nobel Prize for computer science. Right? And as part of a speech that was given I think, on the Turing Award by Jim Gray, there was a description of a new kind of science, as he described, and this kind of forms the base of data science. So the story goes something like that. Thousands of years ago, we had something called the empirical branch of science, where you basically looked at things and wrote them down. Right? That was all. Right? There was not much more than that, and basically, we would nowadays call that philosophy, in a sense, right? Last few hundred years, we had the theoretical branch of science. Newton, right? Einstein. This guy, you know, you observe a phenomenon, you model it, right? Last few decades, we have something called the computational branch of science, which is basically putting little simulations inside machines, like agents, as in, I don't know, simulations of humans acting together, and trying to see how from the microphenomenon, as in agents communicating with one another, we observe higher level phenomena as in society, or something like that. Then apparently, data science is like the fourth step into that, which is the data exploration. There's been a data deluge. I mean, there are tons of data coming from everywhere. Everything you do is supposed to be recorded, and the idea is that hopefully, through tapping through the vast amount of data, we should be able to find things that are beneficial or relevant, and do some modeling at the very least. At the very best, use that modeling to make decisions. So this is something that went on the scientific side, kind of implicitly, right? Then that report came in 2011 from McKinsey, which is a major consulting firm, and it kind of urged everyone to monetize big data, right? So it went out to businesses and said, listen, data is the new oil, in a sense. You have to use data and as much data as you hold and extract as much value as you can from that data, and basically make money from your data, right? That was the kind of message. And they saw data as an area of growth, whereas growth has stagnated in other areas. Data could be one of these areas of growth. And basically, they tried to put some figures on it. But that kind of gave the message to everyone, let's go out now and do data science. And a lot of technologies that were kind of developed as part of these scientific methods, in universities, they started being applied massively in the private sector, right? So, in conjunction with those two events, we have something called the Moore's law, right? I'm not going to describe what the Moore's law is, but effectively, we have a continuous increase in computational power, right? I'm not sure if you can see the graph. These are 2015 results. But basically, yeah, I mean, a number of the methods that we have didn't work that well because we didn't have the computers to do them, right? So we nowadays have, and it's mostly, we use GPUs in a sense for a lot of these. I mean, the graphic processing units that computers have, which we kind of stole from the gaming industry to do AI. But it's fine, it's acceptable. So we got much more processing power than we used to have. So there's this very central concept in science that's called more is different, right? And that's the idea that once changes in quantity gradually become changes in quality, right? So you keep on adding things together, and at some point you have something different, right? Now, all of a sudden, those three things came together. There was the science behind it, there was the business drive, and there was the CPU and the computational capability, right? And hence, more is different. We've managed, and there was data as well, like a massive amount of data. All these things increased logarithmically, and finally, we're at the stage where we can develop algorithms, get you meaningful results in a sense, right? Now, this is kind of the backstory of how we got here in terms of data science, right? But data science, in a sense, not everyone kind of agrees with me. People come from statistics, might say differently, but it's a subfield of artificial intelligence, in a sense, right? It's very closely aligned to artificial intelligence, and a lot of the concepts that businesses use nowadays are basically copied from artificial intelligence, right? There's been a tremendous amount of research over the last 70 years on artificial intelligence, and I'm going to walk you over it. If you talk to doctors, they claim that cancer research has saved more careers than lives, right? And that's the idea. There's a lot of research going on, but not enough results. Yeah. So, artificial intelligence, we have like what? The term was coined in '56, I think. We have 70 years of trying to do this kind of thing. But what are we exactly trying to do? So, I'm going to kind of introduce you to the, let's say, backstory of AI and how we actually got here. Now, I don't know if these two names mean anything, if you've ever seen those two names before. Rorschach, Alan Turing, right? Alan Turing is like something like the father of computing, in a sense, right? He's father, grandfather, and whatever, so he's and godfather as well. So, but also Asby is another computing heavyweight, and they formed in 1949, and that was during the Cold War, in the beginning of the Cold War. They formed something called the Ratio Club, right? Now, that era until the 70s had a completely different feeling to what we have nowadays. You could go with all kinds of crazy ideas, and people wouldn't look at you as if you were an alien. There was that sense that we need to drive progress as fast as possible. There were even discussions in the States of where they could use tachyons, as in they could go basically back in time and destroy Soviet aircraft, right? So all kinds of madness went during, you could do all kinds of crazy research there. And cybernetics developed, which is again very closely aligned to artificial intelligence. And basically, and also Asby and that group that formed around him created this concept, which is central to AI today, that if you understand something, you should be able to generate it. Now they do computer vision in a sense, you need to do computer graphics. If you want to understand something, you should have internalized the process of creating that something. That's the only way you truly understand it, right? And basically that tells you that you need to do simulations in machines, right? On the other side of the Atlantic, we had, in 1956, Dartmouth, which was a major conference, and it basically a number of AI luminaries and cybernetics and mathematicians, almost a massive amount of important people gathered together, and they gave it was an informal symposium in a sense, right? But they started. Basically, they gave the name to the field, right? That's where we get the name artificial intelligence. So, at some point, right, all these people, though they have similar ideas and similar concepts, they start to diverge, right? And I think at Dartmouth, it was one of the cases where people focused too much on logic. Back at the time, we had the notion that if we beat chess, we've created intelligent machines, right? And chess is a very logic-driven puzzle, right? Again, there were a number of other publications from the time that kind of predicted Google, right? This was, Vera Bush was the chief scientific advisor for the US government right, back at the time. So, and I think that was published back at 1949. So all the ideas that really we're applying right now have a history that goes back 70 years. Nothing is new, right? It's just that people are getting accustomed to these ideas. Now, on the other side, the Soviet Union. This is interesting because they try to deliver public services effectively, right? Through the internet. So, again, to Cyberneticians, Viktor Gluskov and Leonid Kantorovich, they basically proposed a system where they would feed the whole of Soviet production, like everything there is to the system, and that every let's say feature of the production, every factory that the system has, every human, every resource, right, into a big system, and that big system would automate economic planning, right? And it would come back with a bunch of numbers, and you just do that, and that would be perfect for everyone, in a sense, right? They were very prominent scientists in the Soviet Union, and they managed to get very high up in the hierarchy of the party, but they never actually managed to deliver this, right? So this is just this is the logo, but they never went to actually implement that. There was a lot of bureaucracy involved, and lots of people were not that happy by being replaced by machines, in a sense. So effectively, what they were telling the Soviet government is that we're going to be replacing your planning departments by massive machines, right? They're not happy with it, so they found reasons not to do it. Another project that got of a similar vein, that got really close to actually being done, was Project Cybersyn, right? So there's this British cybernetician, quite famous, Dr. Beer. He was hired by the Chinese government under Allende, and the goal was to, in a sense, bring Gluskov's vision to life, right? We would plan the whole economy, right? These guys were really ambitious, right, on what they want to do, right? And we will do it using machines, and they even had drawings of control rooms, and the project went, but then it all failed. Now, it's interesting because on a personal level, Beer joined the project as a kind of businessman. He was demanding payments up in advance, and he left as a kind of, let's say, this kind of hippie. He went to Wales afterwards. So it's an interesting. I mean, he kind of realized that machines are not. There are humans in the loop. But if you're a scientist researching all these things, you tend to think of humans sometimes as another kind of machine, right? And humans they're not, politics happen. So that was roughly until 1973, right? So we have this big momentum. People are coming up with all kinds of crazy ideas, up to the level of automating the whole of the economy, right? And that was, that was acceptable even almost everywhere, right? That you use machine to automate processes. It wasn't something quite out of the ordinary. Now, something called the AI winter happens following that, right? So that you have all these exaggerated claims and promises. We're going to automate the whole economy. We're going to build human-like machines. You have stuff coming from Hollywood with robots and nothing gets delivered. Well, things do get delivered, but they are way below the level we would like them to be, right? So this is not the first time that AI is trying to make a move to the mainstream, right? It's probably the second or third time, right? The first time it kind of failed, right? There was something here called the Lighthill report, right? Which basically said, what you guys are doing cannot be done, right? I mean, I have a link to the Lighthill report. It's more complicated than that. But basically, that's what was included in the report. And all research in AI stopped in the UK, with the exception of Edinburgh, Essex, and Essex, right? So that was, that kind of killed. I mean, there have been other efforts to kill it, but that was one big slap. Now, there was, following that, and almost at the same time, we have basically a lack of funding, right? In the Soviet Union, Gluskov cannot get funding to do his projects. Technology is seen as way too disruptive or way up in the clouds, right? So nothing gets funded. And things kind of die, right? So the thing here is that there's in a sense, both communities are involved. The scientific community, I ask, over-promising and under-delivering, right? Which is very common. And a tremendous amount of money was spent on projects that were never delivered. In Japan, for example, there was a project on fifth generation computing. This was billions, right? The project got cancelled in the 90s, right? So people have been trying, right? Since you're not getting anywhere, what's the point? So AI became, in a sense, a theme for sci-fi movies and books. Right? There was still research going on in the background, but it was never part of the mainstream. Right? Now, as I said, through the McKinsey report and through the increase in computing, the GPUs, a number of excellent results that were getting in 2000 were back in business, right? So now people actually listen, right, to what you have to say. Partially, right? I understand that some of it's speculative, but they will you see not as much as a loony as it used to be 20 years ago, right? So, in a sense, AI is really everywhere. All the major businesses, Facebook, Google, Amazon, have dedicated AI labs now, right? I think, I was reading yesterday that Microsoft has 8,000 employees basically working on that. Google, they have labs in London, labs in California. I mean, they're going insane with this thing. And they're betting their future profits on it, right? And on a more local sense, from the university, we work with a lot of local businesses, right? So they are either trying to sell AI services, or they are actually actively selling AI services to bigger businesses. So it's not just a big business phenomenon, right? Local businesses are starting to get into this, right? And they're being very successful in a sense. So we've got local businesses, we've got the big giants. I think everybody in the middle is way too conservative, right? So small businesses, right, they can kind of innovate because there's not much to lose in a sense, right? You're small business. Very large businesses, right, they got an infinite amount of wealth. Everybody in the middle is still struggling on how to tap this, right? And I think part of it is because people tend to be way too conservative on those things. So I'm going to show you a number of examples in AI and decision making and predictions that were actually live, right? So, University of Michigan, the Flint water crisis. I don't know if you're familiar with that, but apparently they found lead on Flint's water, right? So Flint, Michigan is basically in the States, right? This is an American project. So they found lead, and the question was, which homes are at risk of having elevated lead levels, right? And basically, you can't go to every single property in the measurement, right? You can only sample from some of the properties, and using that sampling, you have to infer, right, which houses have possibly the largest probability of actually having lead in the water, right? So it kind of allowed the city of Flint to direct resources towards where it's needed. You can't actively go and check every single home in the area, but what you can do is you can prioritize. If your algorithm with the machine basically tells you that it's very likely that in that address you'll find lead, you just go there first, right? So that was a really successful project, and I think it's still ongoing. Another project on the public sector, but it's used widely, and you've all came across it, is recommender systems, right? So basically, this is what Amazon is recommending to me, but this was made popular by something called the net price, and I'm going to talk about this in a while. Businesses are monetizing this using competitions, right? So competitions are part of the whole, not just monetization, but part of the process of actually getting AI and creating excitement about it, right? So recommender systems is something you've all used. You go on Amazon and you buy some products, and then Amazon will come back and recommend other products to you, right? And as you can understand, this has applications everywhere, right? Songs, music, TV programs, everything, right? Services you provide. Now, there's data journalism, and that's another very interesting case. It is called the Ashland Madison Affair. It was a website basically that had that was basically promising affairs, right? Matchmaking website, and a journalist went in. There was a leak. There was a massive data leak, right? Someone internal took their databases and pumped it on the web, right? And I think the research was done by an independent. They actually found out there were basically no women in the website, and they were using chatbots to communicate, to actually convince men to buy gift tokens, like some thing that doesn't exist really. And yeah, so we have seen people actively using data to, get corporations to account in a sense, I think. So natural language processing, and this might be a project we'll be seeing here. We've got things like topic modeling. given some text, categorize it. Twitter forum mining. This is used very commonly when you launch new products. So you change something in your system, you launch a new product. Do users actually like the product? How do you check? Right? You can do that very intrusively by collecting questionnaires. So going after, after each individual and collecting what they've actually said. But you can actually go over forums and Twitter and check what's the sentiment, in a sense, that your product launch created in the area. Do you like it? Do you hate it? And we're kind of getting better with that. The hot research topic in the area is basically asking questions about images and giving an answer. It's called visual question answering. So natural language processing is becoming extremely popular at the moment. You'll see a lot of chatbots. So effectively, what you have is a massive number of fake agents, chatbots, whatever you want to call them, that sit behind the computer and basically try to imitate the human, right, as good as they can. And this is viewed as a kind of a frontline service, right? You try to buy a car, you have a number of questions in the car, you talk to a chatbot initially, right? And then someone picks up the phone, right, and has a proper chat with you. So, in my view, this is rather interesting in a sense because we are replacing phone service personnel with bots. And it's a very common use of natural language processing. Now, a second competition, and I will come back to competition in a while, Amazon has a prize. If you can keep up a conversation with a human for more than, I think, 20 minutes, you get $500,000 or something like that. So the Netflix prize was 1 million, Amazon is $500,000. And quite a lot of AI has been driven through these processes, basically. Big business coming up with competition ideas, and then going up to the public and saying, well, listen, I want this problem solved, and I've got something that can jumpstart your business instance, like $1 million, right? Can you attack it, right? And it seems, even some research council states to that, it seems that you're able to get much more money, much more value for the money you put in, right? Because you have a lot of teams going after this as a kind of advice. So, coming back to the public sector, predictive firefighting, this is New York's department. Basically, they collect the risk of, they get various features for buildings, as in when was the building built, what materials was the building built from, all kinds of details about the buildings. And they have a database, right, using all these things. And basically, they can tell you if a building is, what's the risk of a building getting fire, right? So again, they can allocate their firefighting resources accordingly, right? Very similar to the message we're seeing with LEED. And you act on risk in a sense. Yeah. Now, this is an example from the United Kingdom, direct interventions, right? So effectively, I think it was, which department did that? The department. But basically, they wanted, there were a lot of unpaid card fines, right? And they wanted a way of personalizing messages or sending them out to people so they could actually pay the fine, because apparently it might even cost more to go and collect the fine than the fine itself, right? So they would send individualized text, and they did a full experiment with it. They sent different kinds of messages to different people, and they saw which people, who responded better to what messages, right? So, and that was, it seems that the response rate increased a lot if you include the name and the amount you have to pay. So it's not a text message that basically says you need to pay a fine. It's a text message that says, hey, Bob, you owe that much. So, it's going quite well. Now, this is something closer to now, right? This is from Dominic Kamen. He was the head of Vote right? He has an excellent blog post about the use of basically data science in basically the vote for the European Union. And they threw everything you could imagine at it, right? So they created new software. They basically hired physicists and computer scientists. They didn't hire that many political scientists. They were extremely dedicated in getting the result they wanted, right? And they knew they were coming in with their initial estimates were not that they're going to lose the vote. So they tried really hard to get to that. Generally speaking, that Dominic Kamen is a very interesting person. So if you follow his blog, you'll see a lot about the use of data science in politics. Then to a more kind of lightweight theme, we have artificial intelligence for creative industries, in a sense, right? People do style transfer. So basically you take images and you create drawings from these images that look pretty, right? And this is used, this can be used for having fun. It's another way of using AI for creative purposes. I mean, you generate music using AI, you generate artwork using AI, all those kinds of things. So, yeah, startups now, really I've never seen anything like that before. I go to AI conferences, there are AI startups everywhere. It's unbelievable. I mean, professors are pinning from universities and they're starting their own businesses. The aim of a lot of these startups is to be taken over by bigger businesses, which is very similar to the way the biotech industry was in the 2000s and the internet industry was in the 90s, right? Basically, people are going out, they create the startups and they develop some technology, or they promise they're going to develop something and they hope that some big shot will come and buy them, right? Now, as all this is happening, right, laws are coming in, right? So there's the General Data Protection Regulation, which you should have heard. I mean, it's a very common thing. People tend to know about it. Which basically states that if you're, for example, a company that sells insurance, right, and you have given a certain quote to someone, you should be able to explain why you gave up it, right? If you call your insurer now and ask them why is it that you're increasing my premiums, they wouldn't be able to tell you, right? Or they wouldn't care, they wouldn't know, right? They will be forced to give you back a sensible answer. Not an answer that the machine says, or the computer says, or my boss said so, something like that. And also, as part of this, you have to be able to track where data comes from. So you cannot sell third parties, so you cannot just collect data randomly without having people's permission to collect the data, right? So you need explicit permission. You need to be able to say where your data comes from, right? If you're going to use data and personalize things for data, you need to be able to say where the data comes from. Now, the social impact of all this, I don't really buy into how much the social change is going to be. So, but I have to present it because it's a big thing on what we do. Now, the idea is, and that was research done in Oxford, that basically about 47% of total US employment is at risk at the moment, because you can basically automate processes, and once this process is automated, someone was doing a job previously, right? That person's job is now automated. They don't have a job anymore. Right? As simple as that, right? I'm not really sure about it, right? There's a massive debate on this thing. If it's going to happen, how it's going to happen, when it's going to happen. But a lot of research is being done at the moment, and what's the impact of actually having all these technologies within society. Right? So, not all is good. I'm making a somewhat controversial comment here as part of the thing. My biggest fear is that we're going to see a level of skilling that we've never seen before. So, most people that have jobs, right, they apply some kind of, let's say, how should I put it, some kind of skill on their jobs, and they take pride in what they do, right? If you automate 95% of it, and you just leave some tiny manual processes you cannot automate in this, then you're taking away what makes you kind of special, right? And what makes you move on the job. So my biggest fear is that effectively people will not accept, and we will have the same problems that we had in the US and UK in the 50s and the 60s when the people tried to do this first time. People are not going to be happy, right? And they will have legitimate reasons, right? It's not like they make these things up. But at the same time, those reasons, unless something is done about them, will stop progress, right? So there'll be a point where we can automate jobs, but we won't automate them because there's going to be a social impact, right? That's not a big fear of mine. And I don't think that working 70 hours per week to compete with machines is a solution, right? So, be more productive than an algorithm, right? You could potentially try, but it's a game. It's a losing game. Now, again, sharper swords, faster horses. We are very, how should I put it, conservative in our approaches, right? So effectively, a lot of the things, a lot of the requests that we get is for people to slightly increase their, what they're doing already, slightly improve it, right? There's a kind of reluctance to go for things that are further away and actually implement them, though it's doable, right? So people will go for small incremental changes. Hence, I think it was Henry Ford quote, I'm not sure if it's that, people would prefer faster horses than cars, right? In a sense, or you don't need gunpowder, you only need sharper swords, or something like that. So, you know, we had all these promises. I mean, Blade Runner, the film took place in 2016, right? That's a very futuristic film. You were supposed to have androids by now. We get nothing like that. I don't know if you remember Back to the Future. There was a hoverboard in there, right? We don't have hoverboards. So, lots of things happen. You know, we never got to the point where we rolled out radical technologies. Though, and this is a piece from the Industrial Strategy Green Paper released by the government in 2017, it seems like this is changing. It seems like the goal is now, or at least that's what it's claiming, right? That we'll try to do things that others don't, right? So there's understanding, I mean, it seems like people understand this at a certain level and they'll try moving forward faster, right? Now, I have a number of slides here that are somewhat generic. But there's the idea of progress, right? And how do you design services that will actually improve people's lives, right? And again, I'm pointing back to, I mean, the book was not written in 1988. The book was written, I think, in the 60s or something. It's called The Human Use of Human Beings by Winner. So basically, this debate about the impact of AI in society has been on for a long, long time, right? And there is that explicit belief that modern societies, we kind of think that our days tomorrow our lives tomorrow are going to be better than the lives yesterday, right? This idea of progress, right? And this is kind of embedded. Not every society has that, right? But we do. So I'm kind of skeptical in a number of things. I mean, we haven't seen as much progress as we like. That's what I'm saying, right? So. Again, coming back to the more business side of things, there seems to be a movement from reactive to predictive. So you don't go to people's places when they catch fire, you actually try to find which house you're more potentially catching fire, and then you take measures. From the generic to the personalized, you don't have a salesman selling the same thing to everyone, you create personalized services for individuals, right? Predictions to causal inference, you actually care about the causes of certain things, right? So as to kind of help you make decisions, and from black boxes to individually explained, right? So we actually care about giving explanations for the algorithms that, you know, what's the machine doing, right? So it's no longer someone on the phone giving you an answer about the service that you can do. Now, how would I go? That's the next answer. In creating an innovation strategy, right? Not everyone has to agree with me. I would basically follow what Netflix and Amazon have been doing for quite successfully for quite some time, and DARPA as well. I would create massive competitions. So think of the problem of waste management, right? Ideally, you would like the waste to disappear, go to Mars, right? You can't have that, obviously, but you can ask the public for really innovative solutions on cutting down the time that it takes to process waste, to move waste, cutting the amount of time it takes to move it around, to how do we produce less waste, I don't know, whatever. So by creating those competitions and demanding solutions, right, that's key as well. You can't just have a proposal, right? What all these competitions have is they create an environment where different people could actively compete and provide better recommendations, which was in the case of Netflix, right? Better movie recommendations, right? So once you create an environment where people can actively go in and tinker with your services, as in when you let the public get access to data and you put price tags on it and you try to create competitions around it, then I think, as in the case of Netflix and Amazon, people are going to catch up with that and they're going to come up with extremely innovative solutions using themes that you have never imagined. And you don't have to do it for yourselves. I mean, you can partner with third parties to deliver something like that. There is the concept, a central concept, and that's a central concept of AI, is the concept of monitoring things, right? You need to measure. If you have got no measurements about what you're doing, then there's no way of doing any prediction or any assessment, right? So the more you measure, which can range from air quality to road traffic to whatever, the better AIs you'll be able to make, in a sense, right? The other concept that again, think of data as a new oil, right? So you would need to create data services. I mean, ideally, I would like to see data streams coming from everywhere and third parties being able to tap on them, right? So you can have small new businesses coming in and using it the same way they use the internet in a sense, right? So the internet created kind of a massive boom, yeah, in businesses. If you could do the same thing with data, right? If you can create an infrastructure where data comes and goes continuously from everywhere to everywhere, in a sense, right? People can capture that and use it. And then hopefully you will have, you create the public utility. Same way the internet is all, is all utility, electricity, water, right? So it's the data public utility. And then who knows what comes out of it. Some of these things are, the university has a platform where we can kind of embed knowledge within third organizations and we can help with the development of new services, new techniques, new methods. So, and we've been doing that with local businesses quite a bit and quite successfully. There's, as I was saying, no presentation of AI is complete without adding much of a terminator. There's a lot of discussion going on about AI safety at the moment, right? Effectively, almost all of the AI startups, I'd say with some exceptions, signed a letter to the United Nations saying, don't create autonomous robots, right? Or ban autonomous robots. Thing is, however, these guys don't create autonomous robots to begin with. It's the big defense contractors that do. So it's kind of, saying don't create robots, but this could happen, but not by them. So I'm not that worried about this. I'm not worried about, there's a lot of discussion about clear-ups. I'm not worried about any of this. But I'm really worried is target advertising and the impact of AI in the workplace, right? People's jobs. Summing up, so there's a lot of hype, right, around AI. It's good for us, in a sense, because we can talk about all these things. It's not, we're not seen as loonies anymore. There's a lot of potential. It's kind of hard to get people, people kind of imagine how they'd like to use it, but they end up not using it, in a sense, right? Because of certain, I'd say, I wouldn't call them bureaucratic, I'd say, because of certain momentum that exists within organizations, the processes that we're seeing are not as disruptive as I'd like them to be. I think we should be more conservative, like us from the scientific side, more conservative when it comes to claims, as to how fast and how far you can go using these things. And third parties to the university, businesses and local government and government should be more ambitious with their goals, right? So I think that we should see a kind of a reversal, in a sense, on the way we use AI. And that's it. Thank you.
Thank you very much. That was really, really helpful. Just so that everybody knows, if you know of anyone that's missed this presentation, we're also videoing it, so we will make it available to others who are coming along later on in the series. We have 45 minutes for questions. If any of you have any questions for Spiros, we're happy to take them now, or if you think of some after today, let me know and I'll pass them on.
I'm a little bit confused around the difference between something like Uber and what you described as what is AI. So I see the Uber as a company that's taken advantage of an app around getting me to places faster, more cheaply than the taxi service. I didn't consider it as being AI making.
So it's all AI, you're absolutely right. It's nothing to do with AI. However, Uber at the moment has a lab. I think it has invested $500 million to that lab on creating automated cars. Basically, driverless cars, right? So they're not. The business doesn't have to be about AI, but they're trying to automate parts of the business, basically remove the human from the loop. Like that's what Facebook. Another example with Facebook, which is like a horrid example. You know how in Facebook you got all these pictures where people. There's a kind of censorship in Google. You cannot do overdo it with gore, for example, right? There are actually people that go on Facebook and check every image, right, that people upload, right, to kind of discern if it should be made public or not, right? You cannot upload anything you want, right? There are people doing that. There are humans doing that, right? So Facebook would love to be able to do that without humans in the loop, right? Without having a human actually checking your single image, because it's actually very traumatic for people that have to go through all these things. So so that it's not, you got the services, but AI is coming in and automating.
Richard?
Yeah, so I think it's all very exciting. I'm sort of slightly worried, I suppose, about what the capability and capacity is in public services to take advantage of AI. So when you say, for example, that Microsoft have got 8,000 people working on their sort of AI component of what they do, it sort of begs the question in my mind that, you know, we start to think about this in the county council about what we might do, but we don't have 8 people, you know, to do this stuff, and we don't have the same, you know,
capacity
spend or the capability. So how in the public sector do we get to grips with this and do actually exciting things when we just don't have anything like the resources that other people have got to spend on this stuff?
So this is why I mentioned competitions, right? So the idea is that you won't be able, given the structures that exist nowadays, to drive all that research by yourself, if any research by yourself, right? But what you can do is that, in my view at least, you can very well scope the biggest needs. You have expertise in certain areas, right? What are the needs of the local council, what are the needs of the local population, right? And you can frame these as explicit services, right? And open up your data to the public, right? Or to third parties, right? So in a kind of a fairer competition is because you'll get, if you just start the project, right, there's a large degree of uncertainty as to where this project is going to go, right? And that might take years before you get anything, right? With a competition, you'll get something before you even pay anything, right? So if I was resource constrained, I mean, if I had no money, yes, I mean, money whatsoever, you can't do anything, right? But if I was severely resource constrained, I would create as many, and I would put, I mean, if you, I mean, the total budget for Netflix for that competition was like $1 million, right? For Netflix, that's nothing, yeah? But the quality of the results they got was massive, yeah? So I can envision a situation where the council at least tries to do things like that, right, in a sense, and they create those competitions, and hopefully they'll get, you know, you put 20,000, 50, 60,000, that'll be enough to jumpstart a local business, right, to help, you know, based purely on ambition, they're going to deliver something superb, right? And you make it so that the answer to the competition is not trivial, right? The business cannot just take that without doing any research and delivering a solution. So I'd see that more as a model for the public sector. So, you know, monetizing third party, you know, helping third parties come to you, right? Creating an echo, I mean, telling them what needs to be done, and they'll, you know, look, sorry.
Questions?
So isn't that the transformation challenge? It's called the
Challenge prize.
Is that what that was?
Yeah.
Yeah.
But I think there are sort of bespoke platforms, right, for these types of competitions. Is that right?
Yeah, there are some, yeah, like Kaggle, yeah.
Yeah.
But you don't, I mean, there might be too I mean, I don't know your budgets, right? So some of these things might be too expensive to start with, right? However, I think they're the cheapest solution. And they will, I mean, if you want to create, let's say, a hub of AI businesses in Essex, right? This is how to approach it. I mean, we have these problems. This is an amount of money that you can tap into if you can solve some of them, right? And let it, you know, spend a year. You know, usually this competition lasts for 6 months or something, right? Come up with an answer, you know, 6 months.
How far into the future do you think AI will have an impact on complex human behaviour? So the psychotic and the delinquent behaviour in social care is different to paying your fine for something like that. So when do you think how far down the road will we have AI helping us with that type of social care, children's social care?
I'm not sure about children, right? So the first bot that was ever created was called Eliza, right? And it was trying to imitate a psychiatrist, right? And that's because, a psychoanalyst in a sense, and that's because it was easy. Basically, it was reflecting the questions back, right? Trying to do some introspection. So it was easy to, you know, once you stop being that mindset that I'm talking to psychiatrists and, you know, the whole thing died. But now, I know there are businesses that are trying to get going into this, right? They try to create platforms for automated healthcare, right? Whether they are successful or not, I cannot tell. So I cannot put a number. I know it's being done. I know it's being commercialized, which is different than being at a university, right?
Yeah.
Once it gets to the business level, someone will at some point try to sell this, right? I don't know. I mean, people have tried making predictions in the past. They all have failed. So I'm not trying to make them.
service trying to use a clinical imaging tool, which has a degree of AI built into it with Python scripts, against aerial photography following something that was done in Athens to find things like swimming pools in people's back gardens.
Right.
Because to use satellite imagery every day, someone checking over that every day, is not possible. However, I can do it because I have full access to that data. I can see a problem, certainly at my local authority, about providing transparency and openness of data. And your first step surely would be to set up the infrastructure to enable that openness and transparency. Because there is a substantial resistance, certainly even between departments at Basildon.
Yeah. So it's really hard, right? So you wouldn't like to see your hobbies or your personal life in a data set somewhere, right? So there should be some level of anonymity, at least, right? And people are doing substantive research on how to anonymize things. Even, I mean, basically you can take a name out, right? But that's not good enough because people can infer who did that based on their behavior and other things, right? So there's substantial research on that. The University of Essex has something called the UK Data Archive, right? And they focus on exactly these kinds of problems, right? They go from clean rooms to techniques and processes and methods for actually getting it out in a safe way that can, that can adhere to requirements. So I would go to the university basically. That would be my approach. If I want to do something that includes data and I want to use,
Well, certainly the only experience Basildon has had is when we used pseudo-nomination tools used by Essex County Council and brought that into the fold. But even then, I could see people having a reaction against it at a local level.
Yeah, it's entirely possible. I mean, if you provide certain guarantees, I wouldn't worry that much. I mean, I would worry the same level of. I mean, you can get people complaining about anything really, right? But if you do your job properly, then you should provide certain guarantees that this is not going to happen. And if the job is done properly, then I can't see a problem.
Any more questions? I've got a question then.
Sure.
You said on one of your slides that the university would be able to help and was willing to help, I think,
Engage,
in
yes.
terms of engaging. We have a challenge lab Wednesday and Thursday. Some of the challenges that we've articulated, you've already mentioned. We'd be really keen, obviously, to work with the university. What sort of things were you thinking when you wrote that on your slides?
Right. So I was thinking basically, I mean, I live in Chelmsford, right? So my biggest problem is waste management. They don't come that often as I would like, the garbage collection. And I was thinking about services on a personal level, the services that the councils provide that affect me in my daily kind of life, right? Which could include waste management, I guess, the website, improvements of that type, right? I didn't have anything specific in mind. I mean, you see all this project, I mean, the projects the fire departments have done, the projects that, the City of Flint has done. You probably know far more about the area than I do. I mean, we do methodology, really. We don't engage as much, So hopefully, you should be able to tell us, apart from my kind of standalone perception of what the council does, you should be able to tell us more about what's to do.
Any more questions, thoughts, reflections?